What I'm about to show you may at first not seem true, but I guarantee you in the next video I will show you absolute proof of what I am stating is true and correct. What most people know about magnets is only a part that creates misconceptions. One of the misconceptions I'm about to show you right now. Now, when we think about magnets, we always think that likes repulse and opposites attract. And generally this is the case. But when we do our experimentation as children, we forget to do all the experimentation that a scientist should do. When working with the same size magnets, now these are simulations just for display purposes. We have two magnets the same size roughly, each has a north and south. They are aligned across this axis right here. Now, if we try to put the two souths together, or the two norths facing out, we know these will be repulsed. And that is true. Then, if we try placing them together in the configuration where we have north, south, and north again, or south being next to the North Pole, as we see here, they will attract. This is the case almost always. But when we take our experimentation farther, we get a very interesting thing that occurs. When we start using different size magnets, we discover, and I'm going to show you this with real magnets, but first I want to show you what happens when we try to put north to north and there's a certain size differentials. We can actually get the north to stay in the center, the very center. When we try to get it to stick to the outside, it repulses. It wants to shoot off, come off, but it will stay to the center. Now, when we reverse it and we try to stick it to the center, it wants to stick, but only around the outside edges like this. It does not want to be in the center. This wants to be in the center in that configuration, but not on the outside. This direction, it wants to be on the outside, but not on the inside. Now, in this case, I am telling you that there are two magnetic fields being presented or expressing themselves on a magnetic face. Okay, now what we have here is a expression of how this is working. So our north is attracted to the outside edge, and our south is attracted to this center, only it's smaller and the same size roughly as the Z, or you see there, or the north when it's turned correctly. And the same is present with the other side, thus making it seem that there is an outer pole that actually encompasses or covers this inner pole. Therefore, though it seems like when we do this function here and we put a north to a center north and it sticks, and then the other side sticks around the outer periphery, what we're actually seeing is there is a magnetic field underneath here. And when we use different sized magnets, roughly in this size comparison, which I'm about to show you with real magnets in the next video, we will see that this is the way it is. But we've never tested this. Thank you.